we move ahead to the next module of electrons and photons, and in this module we are going to learn few basic numericals that we require to understand the chapter. Before starting with the basic numericals, we need to understand that what are the formulas that we require. The energy of the photon, as we all remember, is given by E is equal to h nu, or it is also given as hc by lambda. Again, photoelectric work function, that is given by W naught, which is equal to h into nu naught, which also equals to hc by lambda naught. For photoelectric emission to take place, E should be greater than or equal to W naught, that is energy should be greater than or equal to work function. Frequency should be greater than or equal to the threshold frequency, and wavelength should be less than or equal to the threshold wavelength. The first question is as follows. Photoelectric work function of a photosensitive material is 3 into 10 to the power minus 19 joule. Calculate its threshold frequency and threshold wavelength, where the values of H and C are given as follows. So first, while solving any problem, let us write down the given data. The given data is that work function is given as 3 into 10 to the power minus 19 joule. Also, H is given as 6.63 into 10 to the power minus 34. The value of C is also given as 3 into 10 to the power 8. To find, what do we need to find? We need to find threshold frequency, that is nu naught is equal to question mark, and threshold wavelength, that is lambda naught is equal to question mark. So to find this, which formula do we require? Yes, you guessed it right, students. The formula is W naught is equal to hc by lambda naught, which is equal to h into nu naught. So to solve this problem, we will take our given data on one side. Now to solve it, we know that W naught is equal to h into nu naught. So the first thing that we require is threshold frequency. So can I say nu naught will be W naught upon h? Yes, we know the value of W naught. Can we substitute? Yeah. Again, we know the value of h, that is 6.63 into 10 to the power minus 34. Now on solving, we get the value of nu naught, that is the threshold frequency, as 0.4525 into 10 to the power 15 Hertz. So students, it's very much simple. Again, to find out threshold wavelength, we'll take our given data on one side. We know that W naught is equal to hc by lambda naught. Can I say I have hc and can I have W naught on one side, because I need to find out lambda naught? So lambda naught is hc by W naught, in which h is there, c is there with us. Again, we have W naught which is there with us. So I substitute all of that data. On solving, I get the answer as 6.63 into 10 to the power minus 7, that is 6,630 Armstrong unit. So students, this was very simple and basic question. Let us move ahead to the next question. The next question says that if a light of wavelength 4000 Armstrong unit is incident on a metal surface of work function 5 electron volt, will the photoelectrons be emitted or not? So my question is wavelength 4000 Armstrong unit. So they wrote lambda is equal to 4000 Armstrong unit, which they can write it as 4 into 10 to the power minus 7 meter. Again, we can also write work function is 5 electron volt. Now if I have to write electron volt in SI unit, I need to multiply 5 by 1.6 into 10 to the power minus 19 joule. Again, moving ahead, we can write W naught finally as 8 into 10 to the power minus 19 joule. What do we need to find out? We need to find out, will the photoelectrons be emitted or not? To find this out, we move ahead to solve the problem by taking the given data on one side. Now, for photoelectrons to be emitted, as Mr. Einstein rightly said, that energy should be greater than or equal to photoelectric work function. So, we need to have work function, but we need to also have E. Work function we have removed already. We need to now work on E. How do I find E? I know E is hc by lambda. Do we have the value of h? Yes. Do we have the value of c? Yes. Substituting both of them, again lambda we have removed as 4 into 10 to the power minus 7. Now when we solve this, after solving, we get the value of energy as 4.972 into 10 to the power minus 19 joule. Now when I compare this energy and this work function, can I say energy is comparatively less than the work function? So will the photoelectric emission actually take place? No, no emission will take place. So students, with the help of this module, we started solving the basic problems of electrons and photons. Thank you.